All right, let's get right into it. There's this huge debate blowing up right now in the AI community, and it's all about a really fundamental question. How do we give our AI models knowledge, memory? And the answer is changing way faster than anyone thought possible, all because of one very bold claim that's been making waves. And this is it. It started with a simple post on Reddit, flat out declaring that a core technique, Retrieval-Augmented Generation, or what everyone just calls RAG, was suddenly a thing of the past, obsolete. But is the story really that simple? Or is this just the first tremor of a much, much bigger shift? Well, in this explainer, we're going to pull that claim apart and figure out what's really going on with AI memory. And it really all boils down to this, the million token question. You see, a massive, almost unbelievable leap in AI capability just happened, and it's forcing developers to rethink everything they thought they knew about how AI remembers things. To get why this is such a game changer, we gotta rewind a little. For years, one of the biggest roadblocks for AI was its memory. Its working memory was tiny. Models could only handle a small chunk of text at a time. Think a few thousand words, tops. Anything more than that? Poof, it was gone. And that was a huge problem for any kind of complex task. So this limitation led to two main strategies for giving AI the information it needs. And these two ideas are right at the heart of the debate we're seeing today: the context window and retrieval-augmented generation, RAG. The context window is pretty much exactly what it sounds like. The best way to think about it is as the AI's short-term memory. It's all the info you feed the model in a single go: the prompt, your questions, the data, everything it can see in that moment to come up with an answer. But for the longest time, that short-term memory was, well, it was really, really short. Until now. All of a sudden, models like Google's Gemini showed up with a 1 million token context window. And look, this isn't just a small step up. This is a total paradigm shift. The AI short-term memory just went from being a little notepad to an entire library. So what does a million tokens actually look like in the real world? Well, imagine feeding an AI 50,000 lines of code to debug, or the full text of 8 novels to analyze, or transcripts from over 200 podcast episodes, all at once. This is the breakthrough that made people stand up and ask, hey, if we can just give the AI everything up front, why do we need the old methods anymore? And that brings us to RAG. So if long context is like giving the AI a massive library to read all at once, RAG is more like giving it a brilliant, super fast research librarian. Instead of just dumping everything on the model, RAG is smart. It first goes out and finds the most relevant snippets of information from a huge database, and then hands just those key pieces to the model. It's a targeted, efficient approach that was absolutely essential when memory was so limited. So the choice seems obvious, right? Just throw everything into the context and call it a day. Well, not so fast. Here comes the reality check. The idea that long context is a RAG killer makes for a great headline, but when you actually start building with it, the trade-offs get complicated. And this really frames the two philosophies perfectly. On one hand, you have the long context pitch, which is all about simplicity. Just give the model all the info. On the other hand, you have the RAG pitch, which is about precision. Just give the model the right info. And as developers are quickly finding out, that little difference is everything. And you don't have to take my word for it. This quote from that original Reddit thread just gets right to the heart of it. Developers who were actually in the trenches trying this stuff out immediately slammed into two giant walls: cost and performance. Just because you can stuff a million tokens into a prompt doesn't mean you should. So here's the crucial part. The trade-offs are real. First off, it's expensive. You pay for every single token you send, every time. Second, it's slow. Processing more data just takes more time. And maybe most importantly, accuracy can actually go down. The models are pretty good at finding one specific needle in that giant haystack of information, but ask it to find several needles at once, it starts to get lost in all the noise. But hey, we don't have to just rely on anecdotes and forum posts. Let's look at the actual data. A recent research paper, AgriQuery, put these two methods head-to-head in a proper showdown. They took a dense technical user manual and had different AI models answer questions using both approaches. And the results? They are crystal clear. While the long context method did okay, literally every single version of RAG did better. From simple keyword RAG to more advanced semantic RAG that understands meaning, the targeted librarian approach just won out. And the real star of the show was a hybrid RAG system that combines several techniques. So the data tells us that RAG isn't dead, not even close. It's just getting smarter. Which brings us to a much more interesting conclusion. The future isn't about long context replacing RAG or RAG winning. It's about building a hybrid system that uses the best of both. It's about creating a smarter, multi-layered approach to AI memory. And this stuff matters. It matters a lot. Because as Bessemer Venture Partners points out here, getting memory right is becoming the new competitive advantage for companies. It's their moat. Think about it. An AI product that remembers you, that understands your context better than anything else, that becomes almost impossible to switch away from. So what does this winning strategy actually look like? Well, it's a stack. It's got layers. At the bottom, you've got the expanded context window as your short-term memory, everything you need for the current conversation to make sense. Then, for long-term memory, you use things like vector databases to store information and user history across tons of sessions. And then, at the top, you use a sophisticated RAG system as your semantic memory. That's the smart librarian who knows exactly which long-term memories to pull into that short-term window at precisely the right moment. So you see, that provocative question from the beginning, which one is better? It was really the wrong question all along. The real innovation isn't about choosing one over the other. It's happening where they meet, as developers figure out clever new ways to layer these techniques together. And this comment from that same thread just perfectly captures where the community is landing. RAG isn't obsolete, but the simple, off-the-shelf version of RAG, yeah, that's on its way out. People are moving beyond just plugging in a single vector database and are now building these much more powerful hybrid systems. But what if this whole debate is just a temporary phase? So let's zoom out and look even further down the road. Because while everyone's been arguing about the best way to feed information into the current models, some researchers are busy fundamentally changing the models themselves. This whole RAG versus long context thing only exists because of how today's transformer models are built. Their specific design, their attention mechanism, is what creates these trade-offs in the first place. But a new wave of research is suggesting a totally different way forward. One really exciting glimpse of the future comes from a technique called infinite attention. Now, instead of retrieving information from an external database, this approach builds a compressive memory directly into the AI's core. It's like upgrading the AI's brain so it has both short-term and long-term memory built right in from the start, letting it handle basically infinite amounts of information super efficiently. And what's absolutely fascinating is how it works. You can see it in this visualization from the research paper. After training, the model's little attention heads, the parts that decide what to focus on, they naturally specialize. Some of them become experts at looking at the immediate local context, acting like a giant context window. And others become experts at retrieving information from that built-in long-term memory, acting like an internal RAG system. It's a hybrid model, but right down at the neuron level. Which leaves us with this final big question. As we build the next generation of AI, are we just trying to build a bigger, brute force memory that can hold everything at once? Or are we trying to build a smarter librarian, one that can find exactly what it needs whenever it needs it? Right now, the answer seems to be, well, both. But with new architectures like infinite attention coming up over the horizon, the future might just be one where the librarian is the library.